In this video, we're going to use the Xbox technique to factor a quadratic and solve for the value of x. So if we have a quadratic in its standard form, we can use the x factor method to factor it if a equals 1. So if that value right there is 1, we can use the x factor. If it's any greater than 1, we have to use the x and the box together, and we call that the x box technique. So first, always try and GCF, take out the greatest common factor of all terms in a quadratic. If that doesn't work and a is still greater than 1, we got to use this next method. So let's just write a little recipe here. See where everything goes. We need to draw an x, we need to draw a box with 4 little boxes inside. We're going to put things in it. What we're going to put on top is real similar to what we already did with the x. We're going to put b, the value of b, up top. We're still going to put a times c down here at the bottom. But as you can see, now that a is greater than 1, a times c is going to be super important. So we always got to remember to multiply those two down here at the bottom. On the sides are still the factors that multiply to get this, right, and add up to the top. So those are our factors here on the side. And then after we get those two factors, we move over to the box, and what we put in this first box is the entire first term. So the ax squared goes right there. You can put that as well, ax squared, or the first term. Goes in the bottom right box is the last term, or c. So c, or the last term. And what goes in our little side boxes here are the factors that we found. So it's going to be the factors, or the sides of the x, with the variable though, and that's kind of something that gets forgotten, but it's super important. So the factors with the variable that's in the problem. So for example, in this problem, x is our variable, so whatever factors we find over here, we got to put those with an x. And hopefully it'll make more sense when we get to an actual problem. And then there's a couple more steps here that we have to do to use this box, but I think it will only confuse you if we don't just get to an example here. So there's our recipe. We're going to follow that using the same problem here. So let me rewrite it. 2x squared plus x minus 3. Okay. So let's apply that recipe here and actually use the real values in this problem. So what is b? Well, b is whatever's in front of x, and if it's not visible, then it's usually just implied that it's a 1. What goes in the bottom is a times c, so 2 times negative 3, that means we put negative 6 in the bottom. And we ask ourselves, what factors of negative 6 add up to positive 1? Well, 2 and 3 are factors of 6, but how do they multiply to get negative 6 and add up to 1? Well, if we make a positive 3 and a negative 2 are factors, they'll multiply to get negative 6, but they will add up to positive 1. So what we put in the box now, we move over to the box. We put our first term, or ax squared. Well, that's 2x squared. Put our last term in the bottom right here. So whatever c is, put it in the bottom box. That's negative 3. What we found our factors to be on the sides of the x's go in these remaining boxes. And it really doesn't matter which goes which. You could put positive 3 up here and negative 2 here, or positive 3 here and negative 2 up there. It really doesn't matter. But what is super important is that we put that variable in the box as well. Alright, so we're getting there with our box now. Now to complete the box and to complete the factoring method, we have to GCF rows and columns of our box here. So columns are the boxes that will go up and down, and rows go from left to right. So we are going to GCF up, and we're going to GCF to the left. So let's look right here at this column here. We got 3x and negative 3. What's the greatest common factor between these two values here? Hopefully you can figure out that 3 is the biggest number that goes into both of them. Let's look at this column. What's the GCF? What number goes into both of these? What's the biggest number that goes into both of them? Well, 2 definitely goes into both of them, but also an x goes into both of them. Alright, and now, so we got one of our sets of parentheses. We need a sign though. We always get our sign from the box right here. So if it's a positive value here, then we put a plus there. If it were a negative value, we would put a negative sign there. So let's go rows now. Let's GCF to the left. Looking at our top boxes going left. What's the greatest common factor? I think it's just x. X is the only thing that goes into both of them. Or 1x. Either way. Look at the bottom row here. I think 1 is the biggest number that goes into both of those. And we get our sign from this box. And so we put a negative. So that's why it kind of matters which direction we GCF, although that's not super important. But it is nice because the sign always comes from the box that's closest. So these two boxes. This one goes up here. This one goes over here. So we got our two sets of parentheses. We got 2x plus 3, and we got x minus 1. It's always nice to FOIL and check to make sure that you factored correctly. So if we FOIL this, we should get what we started with, 2x squared plus x minus 3. Let's see if that happens. 2x times x is 2x squared. 2x times negative 1 is negative 2x. 3 times x is positive 3. And 3 times negative 1 is negative 3. Oops, we forgot the x here. So combine your middle terms. 2x squared, negative 2x, and a positive 3x gives us a positive 1x, or just positive x. We still have negative 3. Well, yeah, that's what we started with. So we know we factored it correctly. These are the correct factored parentheses. In order to solve for x, we set each of the values that are in the parentheses equal to 0 and solve for x. So we got 2x plus 3. That's our first parenthesis set. Set it equal to 0 and solve for x. Subtract 3 from both sides. And then just divide both sides by 2. Scoot it down a little bit. There we go. And that gives us x is negative 3 over 2. But we also have this parenthesis right here. So we got x minus 1 equals 0. And if we just add 1, that one's pretty easy. We get x is 1. Two values for x. It's either negative 3 over 2 or negative 1 1/2. We could change that into a mixed number. And the other value is positive 1. You could always substitute those back into x and check. Make sure that you get the whole thing equal to 0. Let's try and do some more problems here. Alright, here's our next one. B goes up top. A times C goes on the bottom, so 3 times 3 is 9. So factors of 9 that add up to 10. 3 and 3. That would not add up to 10. 9 and 1. Oh, there we go. Sometimes the most obvious factors are the most difficult. Never forget that 1 times a number are also factors of that number. So we did it. 9 times 1 is 9, and 9 plus 1 is 10. In our side boxes here, we're using the variable x, so we put the sides of the x with an x there. Here's 1x, ax squared or 3x squared goes there, and c or 3 goes there. GCF up. Greatest common factor is 3. The sign comes from this box, it's positive. And GCF up this way, it's just x. Go left during the rows here. 3 and an x are the biggest values that go into both of those. Our sign comes from this box, it's positive again. And the greatest common factor between these two boxes is just 1. So we got 3x plus 1 times x plus 3. Let's FOIL real quick. 3x squared plus 9x plus 1x plus 3. Combine our middle terms and we end up with what we started with, so we factored correctly. Set each of those parentheses equal to 0 and solve for x. So 3x plus 1 equals 0, and we're going to set x plus 3 equal to 0. If we subtract 1 and then divide by 3, then x is negative 1 over 3, or negative 1/3. Over on the other set of parentheses, subtract 3 from both sides, x is negative 3. So another two values, negative 1/3 and negative 3. Solving for x. Let's do one more here. I think we got time. This time we got to draw our own x. And 3 times 4 is on the bottom. Negative 8's up top. So factors of 12 that add up to negative 8. Let's see, 3 and 4, no, 6 and 2, there we go. If it was negative 6 and negative 2, it would add up to negative 8, and it would multiply to positive 12. Create our box here. Over here goes 3x squared. Here is 4, negative 6x here, and negative 2x there. GCF up, it's just 2, that's it. Sign from this box is now negative, so we put a negative there. GCF up this way, it's just x. GCF the rows here, we got a 3x. And these two boxes here, this row is 2, and the negative sign from here goes right there. So we have 3x minus 2 times x minus 2. And if we could FOIL, we could check it. So 3x squared minus 6x minus 2x plus 4. By our middle terms, we get 3x squared minus 8x plus 4. Is that what we started with? Yep, so we FOILed correctly. We can set each set of parentheses equal to 0 and solve. Add 2. Add 2. So we get 3x equals positive 2. And then divide by 3. Sorry, I'm running out of room here. We get x is 2 over 3. It's also x minus 2 equals 0. Wow, here we go. So add 2. And we get x is positive 2. A little bit of a mess there at the end, but we solve for x. We got 2 over 3, or 2/3, and positive 2. So there are a couple examples of using the x box to factor and solve for x. Again, the reason we use x box is if a is greater than 1. In the near future, it may be tricky because, again, you also want to check for that GCF first. But if you can't GCF and a is still greater than 1, you're going to want to use your x box for now. All right.